There
Okay,
you are.
there we are. I think. Am I ready, Tom?
Yes, you are.
By Jove, we're doing number 19. We've had 18 of these podcasts, or as Tom Totten called it on screen, vidcast. I'm not sure. It's somewhere in there. We've done 18 of them. It's the 5th of July, day after. We all had fireworks in our neighborhood. Illegal as all hell, but that's all right. Welcome to the Santa Barbara Astronomical Unit's weekly get-together. Since we can't meet at the Museum of Natural History, everybody will meet here once a week. This is sort of like our Friday luncheons we used to have without Roberto delivering food to us. And we're talking together with what I call the brain trust of our local South Coast, Santa Barbara-based astronomy club. Telescopes are us, the board members and some of the members on the screen. We call it the SBAU Astro Hour. We're also streaming on YouTube. And you can even leave comments or questions, which Mr. Totten will be checking in on. Let's meet the gang, shall we? To talk space stuff. And boy, we got a lot on the plate this week. Our illustrious leader in his 4th term as president, ladies and gentlemen, President Jerry Wilson. Good morning.
Good morning.
Married to Pat Forgy, and we're all still sort of hunkered down in our bunkers here. As we said, running the program, former president, he was in charge when I joined the club years ago. Tom Totten, welcome back again. Well, you've been home, so I love the backgrounds of all these gentlemen on the screen. He's married to beautiful Suzanne, an artiste. Let's check with our outreach coordinator, doing some outreach, not as much as before, ChuckMcP. Morning.
Good morning.
And wife Pat is our merchandise manager. Love to get a report on from her some week, maybe, if she's up to it. I won't hold my breath. At the bottom of my screen, they could be anywhere, I understand. We have a longtime active member and also president of the Santa Barbara Theater Organ Society. But the man loves telescopes. Bruce Murdoch, how are you this morning?
I'm great. How are you?
Got rid of your mask. Well, none of us have been wearing masks on these because we're at our homes. Wife Bonnie taking care of him for, I think, a big major birthday this week, right?
Yeah, I had my 80th this week. We've been married 57 years.
Well, I'm talking about your big 80th, and so we're going to have a big 10-piece band at your door this Thursday, so watch for it. At the bottom of my screen, but it could be anywhere, I understand, Tom Whittemore, former Westmont College science instructor and editor of our newsletter. Morning, Thomas.
Morning, guys.
If I do the cartoon of the week that was forwarded from the president at some point, maybe you can add one of your funny puns to the program. But we got a lot to talk about. And let's start right now. I'll tell you right now, we're going to talk about the nightly sky for this week, July 5th through the 9th. Bruce's birthday is on the 8th. We're also going to talk about outreach just real quickly before I get to the other topics. Saturday night, Kachuma, were you up there, Chuck?
Yes, we did just a slideshow. Normally we would have a slideshow and then telescopes for a star party, but they're still not having gatherings like that, and they're limiting the attendance at the Fireside Theater. So we just did a slideshow on what they would have been seeing if we'd had telescopes.
Okay, you'll be back up there in 2 weeks, right? On Saturday, the 17th?
Yes, on the 17th, we'll be back at Kachuma. Slideshow at 8:30. It's open to the public and free for the slideshow, but they charge $10 per vehicle to enter the park.
Okay, and you're doing the same thing at Carpinteria State Beach.
Carpinteria State Beach on the 14th and the 31st.
Now, our gang can go there. How much of our gang, just out of curiosity, how many members of SBAU are they just surprised campers? Hey, look, Margaret, we got
it's for campers.
Screen. What?
It's for the campers.
Is it?
Yeah.
Do they all show up and gather around and?
Well, the park was completely full, and we only had 86 people show up for the slideshow. So no, not everybody comes. But we have had 500 people show up for the star party part with the telescopes.
I got you. So with the telescopes, if you have a clear sky,
yeah,
you'll set them up. Okay,
well, no, we won't. We're not having telescopes at all yet.
Oh, you're not?
No.
All right. Well, we missed those second Saturday setting up about next to the observatory at the museum. Mm-hmm. The museum is open, but not ready for us, I understand.
Well, the problem is they're in a residential neighborhood and they have a conditional use permit, and there's only so many people who can come there per year. Their attendance is throttled. They have to close if that many people have come. And our meetings and our star parties count toward that. And they're trying to, survive under these conditions. So I think they prefer revenue generating events.
Okay. They're inside though, are they not, at the museum in Fleischmann Auditorium? Are they having programs and our little hall there?
They are having, I'm not sure if they're still limiting attendance. They suggest that you get a reservation to come.
Okay. Well, sooner or later we'll be there. As far as your occulting, we try to check in with you from time to time, not getting much done due to the overcast.
Well, on Thursday night, I believe it was, I ran up the mountain to get above the marine layer and got a positive on an asteroid called Bertholda. But yeah, otherwise the marine layer has been coming in.
I had a question for you, but I'm going to wait till next week because we got so much to cover here. And real quickly, the International Space Station makes nightly visits just after sunset or earlier before dawn, right?
Actually, right now it's doing early morning appearances, I believe. And then around the 12th, it'll start doing mixed early morning and evening appearances, and then throughout pretty much the rest of the month.
And then China's got one up there called the Tianhe 1, which they say is smaller, but you can see it okay, you're saying.
It's only like 40 feet long, and it's a cylinder 40 feet long and like 10 feet in diameter, but it has solar panels, and apparently the predictions at Heavens Above aren't taking the solar panels into account because it's been quite a bit brighter than the predicted brightnesses. So it's easily visible.
Okay, well, we may have a full report from you next week, so get on board. President Jerry, you were sent a compliment by our esteemed member over there, Bruce Murdoch, about how much you had sent to us. Man, you've been dealing with it. I got to tell you, your subscription's not up to Astronomy Magazine. That's where we get our nightly sky. You want me to go through the nightly sky, or you want to cover some of these major topics first?
It's your choice.
Well, let's get through the week. Today is the 5th, and apparently the moon this morning at 7:47 was at apogee, the farthest from Earth. And at the same time, Earth this week will be the farthest or the closest to the sun. Do you know?
Furthest today.
So the moon's the farthest from us. We're the farthest from moon, and those are two different things. Are we at apogee?
Farthest from the sun. Farthest from the sun.
What's what I okay. Well, that means it's a little smaller. We may not notice that. Farthest from the Earth at 7:47 this morning, almost 252,000 miles in the southeast. Aries the Ram at the horizon level with the Pleiades. Any reason to get up and focus in on it?
It's up right now.
Well, yeah, but how much can you see?
Good luck.
Yeah, good luck there. Also, it's let's see, 100. I can't read my own writing. 23.5 degrees above the moon is Triangulum. We're getting the pictures here from Tom Totten. Thank you, my friend. The small constellation known as Triangulum. That's not one of our galaxies going around Milky Way?
There is a Triangulum galaxy, yes.
Oh, okay. But they're calling it a small constellation holding the Pinwheel Galaxy. Now, wait a minute. M35 is Pinwheel, is it?
M33. M33 Pinwheel.
Okay. What did I say? Did I mispronounce that?
Let me point out something about this finder chart, and that is that you see there's M31 up above the line there, and then M33 right below, and halfway in between is this star. And so once you find, I forget the name of the star.
I think it's Almach. Is that right, Chuck?
That looks like Almach, yeah.
Okay.
I think it's Almach because it's red giant.
Yeah. Okay.
And it's a nice double.
Beautiful, beautiful double. Yeah.
My interest with positional is that if you go from Polaris through the middle, this doesn't show on the chart, but if you go through Polaris and through the middle of Cassiopeia, you come to this star. And then you can go equidistant on either side of the star, and you can find the two big galaxies, M31 and M33. Right. Yeah, you don't need to try and zoom in on it. It doesn't, I didn't include Polaris and Cassiopeia in the finder chart.
Jerry, just a quick comment here. In really good dark skies like in southern Utah, say around Zion, those are both naked eye objects. M31's easy to get, but 33 comes through. I actually seen it naked eye.
Yep, I saw them on a trip once where we had a star party at the 9,000 foot level on.
There you go.
And
Yep.
they stood out so much that I was asking our instructor there, Steve O'Meara, what are those bright spots?
Pretty good.
So there
It
were
was
so many
faintly
stars, I didn't
visible
recognize-
from up on West Camino Cielo one night too when I was up there.
Yeah, that's neat. That tells you have a pretty good sky. Yeah.
Well,
Can I
the-
ask, what is the name of that masala? What kind of name is that? What do you think that means?
Well, Allah,
Allah is God, you know.
there you go.
The moth god.
Oh my God. All right, we're starting to get into Japanese sci-fi.
Pretty good.
Which one is the pinwheel?
M33.
33.
M33.
Now,
Yeah.
pardon me for not being as knowledgeable about the sky as the rest of you. I am learning, but is there the big M of Cassiopeia in this picture somewhere?
No,
doesn't look that way.
that's
Oh,
on
I
the
see.
left.
I thought you'd been mentioning her. Okay.
I did, but that's outside of the finder chart. So we don't
It's
have.
kind
the
of,
full
it's
photo.
kind of, it would have been on the upper left up there because you can see the feet of Perseus.
Right.
Yes. Yeah.
Or
Okay. Well,
maybe even straight up.
these
And
two
great-
these two words that I batted around earlier that you helped me get in focus. Apogee for the moon, the furthest from the Earth, but
Mhm.
aphelion for the Earth, the furthest from the sun. Is that correct?
Yeah,
Aphelion
That's
is
right. Right.
Helios' sun.
Right.
okay. Gotcha. And that means we're not exactly 93 million miles away. Our astronomical unit is 94, I guess, another million miles further, perhaps. So it's
Well, no, the average distance is our astronomical unit.
And that's
Yeah.
not 93.
and
Right.
thank
You
God
know, we're
for
in a
that.
slightly elliptical orbit.
Slightly elliptical.
It's about 2% eccentricity, turns out.
I would imagine a completely circular, perfect orbit is very rare in the universe or in anywhere. And
Right.
Alex,
You know,
nothing-
and notice that the position of being furthest from the sun does not coincide with the solstice. Okay.
Oh.
Or with summer even.
That's right.
so we might have aphelion in winter sometime.
What Tom is showing is a picture I took of M33.
That's nice.
And you can see these red spot or red clouds in the galaxy. And they are hydrogen alpha, places where the stars are being born, very much like the Orion Nebula in our galaxy.
Except that NGC 604, that really bright one, kind of at the 3 o'clock position.
Yeah.
That is much bigger than the Orion Nebula area.
Wow.
Yeah.
It's a huge
very
star
large.
forming region.
Okay. Shall we go to Tuesday? Tomorrow's the 6th.
By the way, this galaxy is soon to be under new management.
Yeah.
Do you mind if I make a comment here, Ron? Or you guys?
Yes.
I was just going to say, recently I've been watching the oncoming approach of Venus and Mars. Now, this is a sunset thing, after sunset. And Saturday night, both Venus and Mars was to the upper left of Venus, okay? For those of you who have binoculars, it's really fun to watch this. Again, if the marine layer doesn't come in, night after night after night. So on Saturday night, I noticed that Mars and Venus were within a binocular field of view, roughly 5 degrees, well within. It was closer last night, okay? And 1 week from today, Mars will be a little bit below Venus, only 1/2 of 1 degree. So it's really fun to watch this night after night, as long as we don't get clouded, fogged in.
Yeah.
And on the 12th, there'll be a really nice little crescent moon near them too.
Nice
Just
job,
above 'em.
Chuck. Yeah, right. That's right. Yeah.
What are the odds they ever occult each other?
It happens.
Does it really? I don't recall that ever being said. It's got to be a very rare occurrence.
Yeah, it is.
Mm-hmm.
Okay, there you go. Beautiful. Thought that was a map of Utah at first. Now it's the sky. I see.
Yeah. Tom's jumping ahead to the next night where they're calling attention to the Circlet of Pisces.
Is there something triangular about triangulum?
Yes.
Well, yeah, it's a little triangle.
See it there in
Yeah.
the upper left of this same thing? Triangular.
There it
a little
is.
triangle.
It's a triangle, Ron.
That's the whole mini galaxy. It is a mini
No, that's
galaxy.
the constellation, Ron.
Constellation, Ron.
Well, it's different from the galaxy that goes around our galaxy. Isn't there a triangle? About-
The
The galaxy
triangulum
is
galaxy
really
is that little red dot, M33.
Right.
Ah,
It's
because
often
it's in the-
called the pinwheel.
oh, because it's in the okay. We got about a dozen, don't we? Little small galaxies. What are they
Well,
called?
this one isn't small, Ron. This is a big one.
Yeah.
Well, it's not as big as the huge one that's coming at us.
Not as big as Andromeda.
Andromeda.
Fascinating stuff. Oh, there's Andromeda. There you go.
Mhm.
You like this sky when it's reversed like that, white background with black stars, and then white on black.
It's an
curious.
easier map to read.
It's a really nice star chart.
Pegasus, that's the horse right below it. There, that's a square in that
Yep.
one. Okay.
The Great Square.
Lot
Mhm.
to cover. Shall we go to Tuesday, tomorrow night?
And down below, you can see the Circlet of Pisces
Yeah.
on the end of the thing. It
Oh,
shows
yeah.
that it's a pentagon here with 5 stars, but there's actually 8 in there that are not drawn connected with lines, and they're listed in the talking points.
Is
So-
that the circlet that he's pushing the cursor around right
Yes.
there?
Yes, that's the circlet.
But the word Pisces is off to its upper left.
Yeah, it's just the tail of Pisces.
Oh, it's
These
the
are-
tail. of the
Actually,
fish.
it's one of the fish. These are 2 fishes,
Yeah.
and they're
Right.
tied together with a ribbon. Okay,
Oh,
is the story. And then that alpha way off on the left
Yeah.
is Alresha, which means the knot that ties them together.
I
Nice
see.
job, Chuck. Nice job. That's right. Yeah. The knot. Yeah.
Well, amazingly, your list of night sky from Astronomy Magazine, Mr. President, goes totally different places every day, which is fine. I don't know how often you rise early in the morning, but if we'll go to Tuesday the 6th, a naked eye asterism, there it is. We're talking about it already. The Circlet of Pisces, a group of 7 stars in the western portion of the fish, directly south of another asterism, the Square of Pegasus, just as shown. So you've been doing this for me, ahead of me already. Stars in the circlet, can you name them all, Tom Whittemore?
In the circlet?
Yeah, there's 7 of them. I
No,
haven't-
sorry. No, I can't. Sorry. Yeah.
Well, apparently they're letters from ancient Greek, gamma, theta,
Oh,
iota.
well, yeah, we can do that. But
Oh,
I
okay.
thought you wanted the Arabic names.
Do they have different names, Chuck?
Yeah.
I'm sure they do. Yeah.
Is one of them called 7? Because it said gamma and then /7, then theta,
Yeah.
then iota, and then
That
19.
list lists the unindicated stars in their order around the circlet.
And it just gave it number 7.
Yeah.
Yeah.
Position 7.
And lambda is a Greek letter as well?
Yeah,
Lambda?
lambda's the upside down Y over on the bottom left.
Okay, and then there's Kappa Piscium.
Yeah, Kappa is the K.
Mhm.
And Piscium says it belongs to the constellation Pisces.
Right. Means of the fish, literally. Piscium.
Okay. And they form a circle, interesting. Which,
Mhm.
Roughly.
and is that turned into a cartoon on the inside ceiling of the where we watch the?
I don't know if they have a separate
Jerry.
one for the circlet asterism, but definitely you see the 2 fishes tied by a ribbon. Yeah.
Mhm. Mhm.
Okay, well, let's see. Gamma is magnitude 3.7. The
Gamma's
brightest.
gamma's the right side up Y on the right of the circlet.
Yeah.
Okay.
Right.
And the diameter is about 6 degrees of the whole thing, meaning you could fill 12 full moons inside it. Also, you're considering the galaxy NGC 7074 in the center of the circlet at magnitude 12.5, halfway
wow.
between Theta and Kappa.
Now, this
I
is a Hubble view of that galaxy.
Yeah,
You
boy.
won't see it this detailed in your telescope.
That's the starburst galaxy,
It's a starburst galaxy.
making stars. I know we say that there are star-making areas. Do you ever see one flash on? Is that something you watch like
That's a very slow process.
Is it? They
You
don't
can see them flash out when they go nova.
Yeah.
But there was something called, I think, O'Neill's Nebula in the above the Orion Nebula that an amateur saw brighten up, and it's a case where you have a T Tauri star, which is a really young star, and
Mhm.
normally they're surrounded by a cocoon of gas and dust, but it underwent an outburst and blew off some of the dust and started to show. So
Yeah.
that in effect is kind of like seeing a star being born.
Yeah. I was just going to say a friend of mine who studied for his dissertation, T Tauris, called them baby suns.
Yeah.
Maybe that's.
Yeah.
Well, is there much of it going on around us in the Milky Way?
Yeah.
Oh, sure.
Yeah, that's true. So the Horsehead Nebula in that area of
Yeah, and Orion Nebula and all sorts of other places.
Orion.
The
Wow.
Pillars of Creation in the Eagle Nebula.
Yeah, yeah.
Okay, well, you guys were ahead of me on Tuesday. Let's jump to Wednesday, the 7th, right before Bruce's birthday. High overhead at sunset. Bootis, is that how it's pronounced? Bootes with two little dots over the second O. Bootis the herdsman.
Mhm.
No bright moon in the sky to wash it out. The star Epsilon Bootis's pop-up companion star is Izar. I hope I'm pronouncing it
Well,
right.
Izar is a double star, and the companion to Izar is they call it a pop-up because sometimes you can see it and
Oh,
sometimes you don't. And this is a picture of what it looks like in a small telescope. Izar and its pop-up companion.
Oh, there's two stars in that photograph?
Yeah,
Mhm.
real bright one and a real faint one.
And the smaller one is not Epsilon, but it doesn't have a name? Or they orbit each other, I assume. They're
Epsilon B.
binary. Okay, magnitude 2.4, located 10.3 degrees northeast of Arcturus, which is a star. And it's the constellation's Alpha star. What does that mean? Anybody know?
Means usually the brightest.
The brightest,
Bright.
or it's sometimes called the Lucida. It's the
Yeah.
brightest star,
Okay.
Lucida.
Although some alpha stars aren't the brightest in their constellation, it
That's
wasn't
right,
consistently
that's
applied.
So the dim half of that is Izar, Izar, right?
No, it's the
No.
bright one.
Oh, it's the
It's
bright one. Okay.
If you look close up, it looks like that other picture that was up there a second ago. That's what it looks like close up.
For some reason, they have the term W period, and I mistook that at one point to west, but that's not for west. W Bootis, also called 34 Bootis, with a small scope. Contrast the two, the brighter, larger Izar is yellow, while W Bootis is almost green. Really?
There are actually no green stars, but by contrast, some stars look green to the
Yes,
eye.
that's. Mhm.
Particularly the companion to Sirius, I think it's a companion to Antares. Something that's right next to a red star, and the red star contrast makes the other star look green.
I know
Yeah.
Alpha Hercules, Rasselhag, or I'm sorry,
Yeah.
Rasselgethy is that way.
Okay.
Yeah.
Okay, but it's also a variable star, right? It gets brighter and dimmer over
That's the
time.
W tells you that.
Oh, is that
Mhm.
what that means?
Yes,
Ah.
Well, they start naming them, I think, with R.
right. Mhm.
Why do you suppose we don't see green? It's on the color spectrum. We have every other color of stars.
It is, and it's the part of the spectrum that our eye is the most sensitive to. But when it's a subtle color, I guess, and the rest of the spectrum is competing heavily with it.
And
So
because our eyes most sensitive to green, it tends to wash out and look white.
Yeah.
Oh, okay. Okay. Shall we go to happy birthday, Bruce? Big 80th birthday is on the 8th, Thursday. Moon will pass
Near Mercury.
4 degrees north of Mercury. Is that what you were talking about, Whittemore? Oh, no, you're talking about Venus.
No, I was talking about Venus and Mars, but that's in the
Venus and
western
Mars.
sky.
Okay. I remember now, but you cannot spot till about 85 minutes before sunup. Mercury is at magnitude 0.1.
Wow,
I
right.
mean, bright. The
Mhm.
lower the number, the brighter, right?
Yes.
Moon will be a thin crescent. Both will be level in the sky as they rise in Taurus. That's my sign, about 3.5 degrees above. Let's see, if I get this right. High, an hour before sunrise.
Which will be
And-
tough with our eastern horizon.
Really? Oh, because there's mountains out there.
Yeah.
Zeta Tauri. Am I jumping into another part here, or shall we just
No.
concentrate on? This is still Thursday, but I have a sign that says maybe this is a new one. Zeta Tauri on the tip of the bull's horns. One of the two horns is 0.5 degree above Mercury, which is, let's see here, 46% lit. How can you be 46% lit?
It goes through
So-
phases like the moon, Ron.
Mhm.
Oh, is that what it is? It spans 7. What's the quote sign? Is that minutes or arcs?
That's seconds.
seconds. I'm sorry, 7 seconds diameter.
Very small.
Oh, very tiny. All right. And 8 degrees upper right of Zeta is Elnath or Elnath.
Yeah.
The other
Yeah, it
horn.
means the butting. It means the butting. Elnath means butting. So that star actually belongs also to Auriga. Okay.
You know, it's too bad, Tom Totten, that we don't have the ability Chuck has when he's running the shows in the planetarium to throw on the bull. Throw the horns and everything on, you know, the cartoon.
We put on a fair amount of bull, I think.
Yeah.
They do. You're right.
Yeah, Chuck's got some real good singers.
Okay, Elnath, the other horn of the bull is a star that shares designations with Beta Tauri and Gamma Aurigae. Aurigae, how do you pronounce that? Sitting on the boundary between Taurus and Aurora, or not Aurora, Auriga.
Auriga. I say Auriga. Yeah.
Yeah.
I think Chuz says Auriga, right, Chuck?
Yeah, you'll hear all kinds of pronunciations for these. It's people stumble through Latin and Greek.
Yeah.
Well, are you planning to go out with your telescope, Mr. Bruce, on your birthday? Or do you hear me?
I think we lost him somewhere here.
Well, he's
He's
muted.
muted.
Bruce Murdoch coming in, calling. Check in, please.
I'd unmute myself. I was talking to my wife.
Okay.
Yeah, I will have my telescope set up. We're having a big party out on our deck, and if the marine layer doesn't get us, I'll show them the night sky.
Well, you don't live in Goleta, do you? Inside the city
I
limits?
live 200 feet from the ocean in Isla Vista.
Oh, well.
I actually live in Aria del Mar. I'm east of Isla Vista.
You're gonna
Actually,
get-
west of Isla Vista. What am I saying?
Are you going to get some of those new LED street lights, you think? Your neighbor?
Oh, I'm have to shoot them out. They're good. Well, the trouble is in my neighborhood, the the phone poles are all warped toward the ocean for some reason.
I
So
got
the light standards are tilted up, and they shine in my second story deck. And I've talked to them. They're going to put shields on them. And I said, well, why don't you just put a bunch of washers between the bolts and bring the standard back down? Oh no, we can't do that. That's too simple.
Yeah.
But no, they're terrible.
Thankful we.
And it's the whole mantra that brighter is better. Further down on Del Playa, where I live, in the Isla Vista part, they have 2 of those 130 watt Cobra heads per light pole. I mean, it's just insanely bright down there.
Well,
And they think it's safe, but the trouble is the phone poles are too far apart. So you get a really bright area, then it's dark. Then a really bright area, then it's dark.
I don't
Sort of like when Jimmy Durante left the stage in his,
Oh, yeah.
he would
I
walk
remember
out
that.
through the bright.
He did?
Yeah.
Yeah, he went from one spotlight to the other. Then he tipped his hat.
Okay. I maybe I'm digging up a bad subject here, but nobody went online last Tuesday or a couple Tuesdays ago to be the only person not in favor, right? With the city of Goleta, they had a little virtual meeting, town hall thing on a Tuesday night. What do we got? Coma berenices. Shall we talk about that?
Yeah, no, we didn't. We talked about it before the meeting.
Well, let's really run. Oh, that's next. It's Friday. I got it on my notes twice. Noon moon
Yeah.
will be at 6:17 in the morning on Friday morning. Great viewing. Good luck.
Hard to see.
What?
It's hard to see.
I'm looking at it fine.
Oh,
Coma
the
means.
moon. The moon is hard to see.
Oh, the moon.
New moon is hard to see.
Oh, it'll be a little sliver in this. Okay, so we have in the evening, western sky, the tail line of Leo the lion. Tailing Leo the lion will be
Following it.
Coma berenices. Sounds like a stripper. Small constellation. Within it is the stunning star cluster Melati 111. Is that pictured?
Yeah, Melot. Yeah.
Melat, is that how it's pronounced?
You see it, it's there in the circle, in the little dotted yellow circle.
Oh,
And
okay, it's one of those.
It's labeled as Coma berenices star cluster.
Right.
Melot 111 is an alternate name for that cluster.
And it
And
wasn't
coma berenices, it refers to Berenices' hair, coma's hair. We
really.
get the word comet from
Oh, really? Comet comes from coma, which means
Well, yeah,
hair?
it comes actually from the Greek originally, but yeah.
It means hairy star.
Yeah.
Well, it means a totally different word in medical profession, you know. Remember the movie The Coma? Anyway, Bootis makes an appearance here within the stunning star cluster, Lot 111, between Bootis star in the east and Leo to the west will be the arc of the Big Dipper's handle on the north. Cluster sits 2.3 degrees south-southwest of the moon, and Gamma Comae Berenices. Who is Berenices? Is that a goddess, you suppose?
She was an Egyptian queen, and the
Okay.
king was off in some military campaign.
Right.
She wanted him to come back safe, and so she sacrificed her hair, cut it. She was known for her beautiful hair, and she cut it off and put it on an altar to sacrifice it to have him come back.
And
I
wasn't
gotcha.
stolen, Chuck? Her hair.
Yeah,
I think
it disappeared, and so to kind of cover things up, the local priest said, "Oh, we put it up in the sky," and there it is.
Yeah, thank you. Yeah, that's neat.
The things we learn here.
Yeah.
Well, if the sky is clear, guys, with surrounding dark spots, look for the cluster unaided, appearing as small fuzzy patches of light. Use binoculars and see lots of stars.
Yeah.
That covers our week, courtesy of Jerry, the president.
Just if I may, on that note, you know, I watched the fireworks from the house here, from the backyard.
Oh, you did?
There was a nice layer, okay, over kind of the harbor area after a while that made the sky really dark and black for us here. So I just brought out the binoculars, and by that time, Sagittarius and Scorpius were up, and I just picked off M28, M22, M4, 6, 7. You know, a whole bunch of stuff with, again, binoculars. I've just been doing a lot of binocular stuff. It's just really fun. Okay. And I recommend it to the folks listening. If you have a pair of binoculars, just go out and just enjoy the wonders of the night sky.
Another thing about Coma Berenices is I think that's where the North Galactic Pole points.
I think that's right.
Oh, yeah.
Okay, but is it a represented constellation? Is there something configured on the interior of the planetarium ceiling?
Well, it just shows us a bunch of hair, but yeah, you can see it. It's just that little chevron line thing in the diagram that Tom showed.
Yeah.
Well, coma is the word for hair. Do we get comb, C-O-M-B out of that, you suppose?
Maybe.
Probably.
Probably. It might be a yeah, probably. Yeah.
Well, before you joined us, Whittemore, we were talking about the other shows of pyrotechnics outside our houses and around our neighborhoods long after the 9 o'clock program. Did you get any where you live? Any people sat down?
No, not immediate, but I heard down at a place we take our dog, La Colina, the kids were knocking off fireworks in the parking lot. That's pretty dangerous stuff. That's obviously illegal, you know.
Oh, yeah.
But
yeah, they made
no,
it-
not nearby. Rob.
Yeah, we heard a lot of fireworks, but we didn't see any, and my dog got very agitated.
Yeah.
They were bound and determined not to let you get to sleep till midnight.
Well, I don't sleep till midnight anyway. So the last thing in Coma Berenices is the Black Eye Nebula, Black Eye Galaxy,
Oh,
64.
That's a beauty.
It's a very dramatic and easy to see in a telescope. It has it has a dark dust lane on one side that obscures a lot of the light from the galaxy itself. It's very distinctive.
Yeah. It really does look like a black eye.
Yeah.
A shiner.
it was given number 64 by Mr. Messier.
Messier, yeah.
And globular cluster, which doesn't have another name, M53 is nearby, but not in this
Yeah.
photograph.
Yeah, I didn't show
That's a
picture.
really neat one. That glob is really nice.
Okay, how did you pronounce it, Chuck? Berenices?
Coma
That's-
Berenices is what I've heard.
Yeah,
Very nice.
that's why I say it too, Ron.
Okay, good. Below the night sky, days in the, okay, then.
That's 53, huh? God, look at that.
Fireworks.
Yeah. Yeah.
Oh, what were you looking at here? Is that it? Is that
Yeah,
Berenices?
globular cluster.
Oh, that's the cluster.
Yeah.
How many stars do you think are there? About several 100,000, right?
Looks pretty busy.
Yeah, look at the colors too, Ron. Look at the blues, look at the oranges, you know. These are
God, I love
gorgeous.
it. You grow up with just white on black, and only later on, I don't know if the technology caught up. I don't recall seeing much color in
Well,
nighttime.
they used to use black and white film.
Because it was much more sensitive.
Yeah. But you can tell different things with those colors, can't you? You know, how
Yes.
old the star is,
Mhm.
how big it is.
Primarily on temperature. Yeah. Mhm.
We're going to be back in a minute here to talk about the variable star of the month, if you'd like to, gentlemen, real quickly, our Scooty. But this was the forwarded cartoon of the week from President Jerry. The elderly fellow sitting at the bar, getting smashed, has white hair all the way out to here. It turned out to be none other than Einstein himself. The bartender leans over. Oh, there it is. Space is curved and time is relative. Yeah, okay, guy. I'm calling you a cab right now, buddy.
That's a good one.
I wonder how many people would know what that's all about. You know, the ones that don't are the ones that don't get their shot.
Yeah.
Same people. Well, all right, there you go. We get enough of those every week. I don't know where you get them, but we're not going to ask, President Jerry. Just as long as we're talking about stars, let's slip over to our Scooty. Why is there an R with a period? Is that short for something? Does anybody know?
It means it's a variable star. They start naming them with R, and then
Right.
the name of the constellation. It's in Scutum.
Okay, well, there's also a beta Scooty. It's a brother nearby, I guess. But
That's a different alphabet.
Yeah.
It doesn't mean it's a variable star.
what is this? What are we looking at?
This is the light curve for.
Oh, that's the variation.
Scuti. So
Okay.
along the bottom is the time from February 7th, 2009 to July 11th, 2010. So it's about 18 months of the variable star.
Okay.
You can see it's not exactly a nice repetitious system or, cyclical process. There is some cycles to it, but it's a complex, like a beat frequency.
The Fourier
Okay.
series.
Yeah, you need to analyze it in a Fourier series to see what frequencies it has. It's obviously got more than one simple frequency.
Mhm.
Does anybody know what Scutum means? It sounds dirty.
Shield.
Scutum is shield.
It means
What?
a shield. Shield.
Shield.
Oh, it means shield.
It used to be
Shield.
called Scutum Sobiescanum, right? It was
Mhm.
Sobieski's shield.
Right. Who saved Europe?
It's a
Jan
small
Sobieski.
constellation. Is it represented on the ceiling by anything?
By a shield.
Shield, yeah.
Oh, by the shield. I don't recall seeing a shield. There's so
It
much.
doesn't
up-
attract your attention right away.
Yeah.
It's
There's a
like the
beautiful-
Roman shield. It was round,
Yeah.
Okay.
big round, like a garbage can lid.
And I believe the number is 88. Different constellations are pictured on the interior of our Gladwin Planetarium. And anyway, small constellation bordered by Aquila,
Mhm.
which I probably mispronounced. Aquila?
And you can see the R Scuti is indicated on the finder chart with a label right next to M11 and just down from beta.
Right. Okay.
And
And
M11 is the wild ducks.
The wild ducks, God,
Yeah.
that's beautiful.
It's an open cluster. It's very nice.
The other thing I was going to mention is that the Scutum star cloud is right here, and it's just spectacular. You can see it with your naked eye in a reasonable sky. The Scutum star.
The other finder chart has the clouds.
Okay.
Milky
one of
Way
the
cloud
first-
concentrations in it
Hmm.
there.
apparently,
There you go.
Yeah.
oh, here we are. Our Scooty right there in the middle.
Mhm.
There's one of the first variables ever discovered, meaning they didn't even know they existed before somebody said, that sucker's
No,
fluctuating.
like Chuck said, Ron, the first variable star to be noticed in a constellation is designated capital R. Then it goes capital S, capital T through the alphabet. Then it comes back through the alphabet. It's a crazy system. Okay. But that's the first variable star to be documented in Scutum, the shield.
Do we know where beta Scooty is in this picture, or is that even
Right above it, Ron.
Yeah,
See?
Right there.
That's the B.
Oh, that's the B. Oh, okay.
Mhm.
It's magnitude 4.2. How about our
Okay.
Scooty? What is it? 5.2, a little not as bright. And one of the first discovered, let's see here, an RV.
In that
What?
Yeah, in that constellation, our Scuti.
Yeah, there were naked eye variable stars, Myra and
Mhm.
a bunch of others that were long known.
Mhm.
What percentage of the stars up there, very small, are variable, fluctuate
Actually,
brighter and dimmer
Probably
over
a fair
time?
number.
Yeah,
Quite a bit.
I would say quite a few, quite a few. I
And-
mean, this one has a period of about a half of a year, it looked like. So this, this is a, I would put it in the Cepheid class probably. That'd be my guess.
Well, you did a whole speech, Whittemore, on Cepheid variables. What's different about those than regular?
Well, again, the ones that I was looking at, I wanted to get a lot of data in one night. So I looked at short period variable stars, and they're real interesting. Okay, they're classified under Cepheids. Okay.
Okay.
In fact, they're even classified under Delta Scutis. But mine were really short period, often 3 hours.
Really?
So in a long night, you might get 4 cycles. And so you could look for all kinds of cool details, in these cycles. And sometimes we saw secondary information, okay, where the star not only had a major period, but a secondary period too that was beating against it. Okay.
Okay.
Really interesting stuff,
Many variables, it said in the president's notes, take a time of a period of like this one, 71 to 144 days. So
Yeah.
you guys would have to be locked on it every night for a long time.
Right. Yeah, I didn't want to do that.
Or get the
Tom,
less
how do you
versus
determine
earthly.
the brightness of the star?
Yeah, I noticed
How
that
do
the
you
brightness
measure
of the
it?
star was changing from like 7th magnitude to something like 4, Jerry. Does that sound about right? So,
Do you compare it to nearby stars? Is it visual, or do you have an instrument that you measure the brightness with?
Yeah, it shows it going from about 4.5 to 7.5.
okay, so three ticks, which
Yep.
would be, what would that be, Jerry?
Each
A little over a
magnitude,
decade.
each magnitude is
It's
times
2.5.
2.5. Yeah, so it'd be 2.5 cubed.
Okay, we got a
Whatever.
question from Tim Crawford. He's wondering why some variables have longer periods than others, and some of them are bigger. That's why.
Yeah, I say size is probably the answer. Yeah.
Is Betelgeuse one of those?
It's a variable.
It's a
It's a
variable.
variable star. It's an oddball.
Well, it's a monster.
It tricks us, and I guess it's doing it again, Chuck.
Oh, is it dimming again?
yeah.
Okay.
It was in the Times the other day. Yeah, so it's
Betelgeuse? The big.
it's
the big
noodling
one,
with us again.
Well, in Jerry's notes, it says scientists are not sure why our Scuti causes these long fluctuations, but maybe shock waves inside the star forming some sort of cocoon.
Right. And again, this is information coming from the star's interior that's, shows up on its exterior, on its what we can see. So, a lot of people basically model off of the interior by studying, obviously the only thing you can see is what's going on the surface,
Right.
There was
Okay.
a time, a long time ago, where astronomy was primarily visual, and some astronomer was heard to remark that we will never know about these stars because all we can see is their light.
Yeah.
So, and that was shortly before spectroscopy was discovered. I forget who the
his name, Jerry, was Lecomte. He was a philosopher.
stuck
He
his
should have owned a telescope
yeah
or a spectroscope.
spectroscope.
Yeah.
Well, I'm here to
That
say,
was an amateur,
representing
I
the
think,
vast
that-
hordes of
Mhm.
laymen that don't know much stars, that for most of my life, I didn't know, number one, that most of them are binary, more than half, or at least 2.
Yeah.
And now you're saying not quite half are variable, fluctuate. We'd never know that even. 'Cause we're not going to stay out there for 3 or 4 hours
No.
like Tom Whittemore seeing.
Some of them are short enough periods, or people watching them over weeks and weeks will notice the variation. Algol, the demon star, Myra, people saw these naked eye. I mean, because they varied. They would see that over a period of a year, suddenly it was much dimmer, things like that.
Now there is a paper that came out a short while ago, and I put it in one of our monthly talking points, but we didn't get to it. And the claim, it's a hypothesis, it's not a fact, not confirmed, but it said that every star that's born is born as at least a binary. And they go
Oh.
through a series of processes that cause about half of them to lose their companion. Now they're
Oh.
doing this through modeling. So you get out of a model whatever it is you put in, whether you know you're doing it or not. So there remains to be derived from this some kind of an observation or link to data sets. So it is very, very speculative.
Well, if
Yeah.
our old friend, the sun, Sol, was a variable, we wouldn't have a chance of surviving, would we?
I would certainly be a different Earth.
Yeah.
But
Well,
the
since the
sun
light
does,
output,
the
since the
sun
light
does,
output varies by more than a decade, that means the heat output varies by more than a decade.
Yeah.
You're going to have nuclear winter every so
Right.
often.
I used to be a fan of, I'm still am actually a fan of good science fiction. But back in the early days, 50s and 60s, I read so many different variations on planets. And one of the most interesting one was a civilization that had grown up on an elliptical, a prolate,
orbit.
You're right.
no, a prolate, the planet shape itself was prolate.
Huh?
So it had an atmosphere of Earth density around its equator, but both the poles were above the atmosphere. And so you could only live, and they tried to describe how people adjusted to that and lived, and people were taking hiking expeditions up to into the vacuum of space at one end of the planet and stuff. So there's all sorts of weird things, and now all those weird things, not all of them, but most of them are coming true. We're finding planets. I haven't heard of a prolate planet yet, but planets, gas giant planets that are still gas giants that are rotating in a day and a half around their primary star. I mean, that's just staggering to think of that.
Yeah.
Haumea, the dwarf planet Haumea is definitely a prolate spheroid. It's football shaped.
Yeah.
Really? And then there are planets in the Goldilocks zone that are tidally locked, and you'd have to live on a little strip between the dark and the light on the edge.
Yeah.
But otherwise you'd fry on the side facing the star and then freeze on the other side. Which brings us, incidentally, gentlemen, to the white dwarf. Now, this fascinated me. Jerry, you sent this, so let me read what I got here. From the July 2nd issue of Nature magazine, a different white dwarf star has been spotted. It's a hot cinder, just slightly bigger than our moon, but smaller than our planet. And it's less than 100 million years old. It's a collapsed core of a low mass star. I say low mass, even though it's got more stuff than our sun does, 97%.
Let me explain it so you don't have to read it.
Okay, please, you're on.
So this one is unusual because it is so small. And normally white dwarfs, as you see in this diagram that has the Earth and Sirius B and Procyon B and Van Manen star, that's the normal. So those are names of known white dwarfs, and they compare favorably to the Earth. But this white dwarf is unique in that it's, as the artist illustration shows, it next to the Earth, the white dwarf is about the size of the Earth. And that is very odd. And the models of how white dwarfs are created, they're all dead cinders of stars. They're just glowing by the residual heat as they cool off. But fusion has stopped in all these stars. And they figured the only way that something could have happened that was this small was a collision of two normal sized, planet sized white dwarfs. Now you'd think if you're going to make a smaller star out of a white dwarf, two white dwarfs, it would come out bigger, but it's just more massive. And the more massive it is, the smaller it crunches down to be. So it's got to be something that is got more mass than two normal sized white dwarfs. So that squeezes it down to very tight, but it didn't make it to what's called the Chandra sakhar limit, where it would collapse into a black hole. And the fact that it's supported by the fact that it also is rotating extremely fast, as it would when a massive star would contract to a smaller size, it would speed up.
And also a collision would add to the angular momentum.
Yes, yes.
Plus, when they say 100 million years old, they don't mean the star's total life is 100 million years. They mean it's been 100 million years since it became a white dwarf. Because low mass stars have long lifetimes.
Okay. Do they know the generation? Like they know our sun is a third generation, right?
Second
It's
or
made
third.
of stuff. Okay, meaning other stars before have collapsed, or no, have blown up, and then we're using all the elements it made. But
Right.
this sucker we're looking at is mostly electrons crammed together.
It's mostly helium nuclei, and because it's a small star, this is how our sun will end. And our sun will go through hydrogen fusion to produce helium. And then it may not collapse any further depending on how much mass it has. So the temperature may not get up to a temperature where it can start fusing helium into higher elements. So if that's the case, then as soon as the hydrogen fusion stops, that's it for the star. No one's stoking the boilers anymore. So it's just cooling off.
Huh. So it'll never be a black hole.
Nope, too small.
What's its future? What's it going to end up happening?
It's going to lose its light and eventually become a dark, cold object that's crystallized.
They call them
Really?
black dwarfs.
Yeah.
Well, I guess I missed the part about the helium nuclei, because all I read in your notes was the electrons are crammed together and they don't want to be crammed together. And I guess somehow we get light out of that. It's a
Well,
very
it's really hot, and so that's why you're getting light. But the electrons are kind of what is holding everything up.
Yeah. The
So-
electrons, the gravity wants to pull the electrons in, but electrons have to obey the Pauli exclusion principle, so they can't all occupy the ground state. So they occupy a set of more complex states, very similar to what happens in a solid when you make a solid out of a bunch of atoms. So all these little levels spilled up into a band. So this is it's like a helium core, a crystallized helium core, and then, which will crystallize, and then a gas, Fermi liquid as the atmosphere of electrons.
Okay. Aren't the double protons, which is the center of helium, aren't they also gamma rays? Some kind
Center
of ray.
helium is alpha particles.
Oh, alpha rays.
Is that a right? Is that beta?
It's alpha.
Alpha. Okay, thanks.
Mhm. Yeah,
I think beta are electrons.
right.
Yeah, right.
They originally were called beta rays.
Yeah.
Right.
Oh, but during its earlier life, it only reached the stage of helium, the second element.
Well, what happens is you have a mass of the sun, and then it's gravitationally pulling itself together. And as it compresses, it heats up. And when the core, which is where it's going to be hottest, when the core reaches 10 million plus degrees, then the helium or the hydrogen nuclei, the protons, start merging. They start fusing to form helium. And so then that releases energy that pushes out, and now it resists the force of gravity, pulling it ever tighter. So it just sits there and it burns hydrogen until all the hydrogen is burned. And then the star has nothing to resist its collapse. So it squeezes down more, the temperature inside goes up. And if it has enough mass that the temperature inside goes up enough, then it starts fusing helium.
Huh.
The sun won't do that. It doesn't have enough mass.
Sun will never become a white dwarf.
No,
No,
it
it
will.
will
It absolutely
become.
will.
Oh, it will.
Won't pass through that stage.
What
But it
happened?
won't have any more fusion.
Right.
Well, what happened to all the higher elements that this star made? Did they
Doesn't
break
make any? It doesn't make any because the boilers quit after.
Yeah,
making-
Ron, only really massive stars make the heavier elements.
Oh, like a Betelgeuse.
Yes.
Yeah.
It hasn't reached the iron stage. When it does, we're going to see a big nova somewhere, aren't we?
Supernova.
Okay. But the white dwarfs, as a rule, are about the size of planets,
About the size of planet.
and we can see them in the distance.
Oh yeah, they're all over the place.
Well, I imagine in the distance, the far distance, over 100 light years, you wouldn't be able to see much of a pinprick alike. Certainly not as big as a star, is it?
Wow, they're hot and bright.
Yeah. All
Really?
the stars are pinpricks of light.
I see. But you're never going to have a nova with one of those.
No.
They're just gonna
No, no.
blink out.
Well, if it's got a companion that drops that, and the white dwarf sucks material off of its companion and it builds up, then you get a thermonuclear nova, supernova. Yeah.
Mhm.
So, but
Quantum
that's only if
mechanics.
it's part of a double star.
I got you. But this one, this is the smallest, the one you, do we know where that is?
Yes.
How far away is it and where?
I don't know, but they know.
Oh,
Let's see where the, is that in that?
Yeah, typical temperature for these white dwarf cores is 100,000 kelvins.
Yeah.
And so they really broadcast in the UV too. I mean, they're bright, like Chuck says. They're very bright.
might they have exoplanets around them?
They could.
Yeah.
Wouldn't be very fun being on it.
We're
Well,
down
Tom,
to
if
the
they're 100,000 Kelvin, why don't they then start fusing the helium into carbon?
Because it
Oh,
takes
no, you need extreme
100
temperatures.
million, not 100,000.
Yeah.
Okay,
Yeah, yeah.
okay. I'm off by 3
Yeah.
orders of magnitude. Yeah, okay.
Yeah.
I heavily edit these things and then rewrite them to make them sound simple. I apparently left some data out, so where it is, but
They're saying it's
it's
not
been
far away,
yeah,
so
it's been observed. I think it's 100 light years away or something.
Yeah.
But now we're talking old stars. To reach that stage, they had to be around for a long time, I would imagine.
yes.
Well, our sun is going to take about 5 billion years to burn through its hydrogen. We're about halfway through that now.
No, 10 billion total.
10 billion.
We're about halfway through now.
Yeah, okay. So these stars will be similar. That they will have a lifespan as a sun-like star for about 10 billion years, and then they will become white dwarfs.
Okay, now they're not the flipping around neutron stars that's a totally different animal, right?
Yeah,
Same,
yeah.
same. You know what I'm talking about?
It's also an end stage of life of a star, but a more massive star to get a neutron star and a pulsar and a
Yeah.
magnetar.
Pulsar is spinning with the poles going crazy and fascinating stuff. This astronomy.
More
is.
complicated.
Yeah.
More complicated stars that have done more fusion is covered down there under the last one, I think, which I labeled as it's the Las Cumbres Observatory discovery.
Ah,
Aha.
But we don't have time to get into that.
No.
Nuclear fusion in sun-like star. Oh, that's it. There it is. And it's titled "And Farther Along the Fusion Path: The New Type of Supernova Discovered at LCO." We'll cover that next week. So we've come to a natural division place of where we save stuff for next week.
Yeah.
Plus, you're going to have to add methane on Mars and looking at Ganymede, which is the largest moon in our solar system, right?
Methane on Mars is real interesting. I can sum it up in 1 minute.
Oh, yeah?
Yeah, so some instruments see methane, some don't. So it turns out that's been looked at by a group of scientists, and there are 3 instruments. There's a lander on Mars that takes pictures only during the daytime because that's when it's got good solar power. There's the rover Perseverance, which can take it anytime and only takes it at night. And then there's an orbiter, which looks at it down at the atmosphere, and the orbiter doesn't see anything. So it turns out that during the daytime, all 3 of these instruments are right, but they're all taking different parts of the atmosphere, close to the surface during day, close to the surface during night, and from the top of the atmosphere. And so the stuff apparently is seeping out through the Mars surface at night, and then during the day, something's happening that causes the methane to dissipate. So the real question is what happens to the methane, because methane should last, 300 years or something, according to their studies. So they make the different readings consistent, and they've taken each of those instruments on the surface, and they've taken readings at the other one's time, and they do see the consistency between them.
Wow.
There is transient methane on the surface of Mars that appears to be coming up out of the ground. But again, it can be due to biology, and it could be due to natural inorganic chemistry.
There you go.
and it's been seen from the Earth with spectroscopy, but some people see it and some people don't. So it's the same kind of thing. They were either seeing it when it was pooled in the lower elevations and managed to detect that, or not, depending on when they looked.
Okay, methane's an organic compound, is it not? It doesn't indicate anything.
DH4.
Well, look, we've run out of time, and gentlemen, stay sequestered and stay safe, but get out and have some fun with your wives at some time, and you don't have to wear those masks. Make sure you stay immune, and SBAU.org. I neglected to say that. Tomorrow night we have a big telescope workshop, right, Tom?
Yes.
Okay, everybody, we'll see you next week. Thank you very much for being with us, and let's talk again about cosmos and astronomy. You got it.
Adios.
All right,
Bye now.
everybody.
Guys.
See you next Monday
Bye-bye.
for number 20. Bye-bye.
Good show, Baron. Later.
Thanks.
Please visit www.sbau.org.
Won't let me go. Still hear me?
Yeah.
Yeah, it's just a matter of clicking end on the bottom there.
I am.
We're doing the
I'll
end
let you
title
go.
credits.
You